Hello everybody, welcome back to another video. Today we're going to be solving a very interesting problem. Sorry I haven't uploaded a video in a while. I was doing a lot of stuff and I've been working on some future video ideas. Let's get right into it. Alright, so analyzing the equation, immediately we have x is equal to the square root of 1 plus the square root of 1 plus the square root of 1 infinitely many times, which makes it a really weird and honestly cool problem. So how can we even approach this problem? We're trying to find a value for x in numeric form, if we can even write that. And the answer is actually really shocking. So if you watch my other video, you'll notice something right away. This inside radical of square root of 1 plus square root of 1 plus infinitely many times is actually x indeed. So if you didn't catch that, let me rewrite this. X is equal to the square root of 1 plus square root of 1 plus square root of 1 plus dot dot dot. Now I'm going to rewrite the same thing, but just using different colors. X is equal to the square root of 1 plus the square root of 1 plus square root of 1 plus infinitely many times. So immediately, now it becomes very clear that this inside radical, the square root of 1 plus square root of 1 infinitely many times, is indeed the definition of x, as we claim so. So right here, I wrote x as we said in the beginning, and I wrote it here. This definition is literally just what's inside the radical right here. So we can rewrite this equation as x is equal to the square root of 1 plus x, because that is what x is. X by definition is this massive thing that goes on infinitely many times, and since that's exactly what matches up here under the radical, the larger radical, we can just replace it with x. So now we have our new equation and everything becomes really easy to work with. And we're going to be analyzing the solution as well. So let's write this. Let's try to solve for x. We can solve for x by squaring both sides, then subtracting x and 1, like this. So all it is just x squared equals 1 plus x, and then subtract from both sides. Now we get x squared minus x minus 1 equals 0. Could we try factoring this? That doesn't look like an easy factoring pair. X plus something, x minus something. It doesn't look like we can easily factor this. So let's pull out our quadratic formula from Algebra 1. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's identify our constants. So a is going to be 1, b is going to be negative, I'll put it below. A is 1, b is negative 1, and our c is going to be negative 1. So ladies and gentlemen, that means the solution to this is going to be x is equal to negative b. So negative b is going to be negative 1 plus or minus, and we'll address this in just a second, square root of b squared, negative 1 squared, minus 4ac all over 2a. Let's simplify. Now we get x is equal to 1 plus or minus the square root of 1 plus 4 all over 2. And we simplify more, we get 1, x is equal to 1 plus or minus the square root of 5 over 2. So are we done? Is that our answer? Well, actually, there's a lot more to this answer than what you can see here. And it's a pretty cool number, which I'll get to in a second. But this is actually not the answer. You see I included an extra solution of 1 plus or minus, but if we look at the original problem, x is equal to the square root of something. The square root of something, by definition, is always positive if we're talking about real numbers. So the square root of x always returns a positive or 0 number. So it's always greater than or equal to 0. Because square root of 5 is greater than 1, when we do 1 minus square root of 5, that gives us a negative number on top and a positive number below. And negative divided by positive, it will give a negative number. But x can never be negative because by definition, since we have the radical here, that's what x is equal to, this has to be strictly greater than or equal to 0. So that means we can write the solution for x by dropping this negative. So x is equal to, I'll write this in white, x is equal to 1 plus the square root of 5 over 2. Now, this is actually a really useful constant in mathematics, and we call this number phi, or the golden ratio. I'll write it out here. The golden ratio. And I think it deserves its own color because of how cool it is. The golden ratio is seen all throughout the world around us. It's the first time I've used yellow, actually. But the golden ratio is approximately 1.618, and it keeps going. And it's known for its characteristics in nature as well. It turns out a survey was conducted about an image of a dog, I believe it was. Oh, I'll begin to draw a dog. I'm not the best at... Oh, that is definitely not a dog. Well, I tried. How about I try that? Yeah. So it was a portrait of a dog, and there's a survey conducted regarding what is the best ratio of A to B, or I think it was B to A, of this portrait that people like the most. Now, averaging everything out from different likeness and different options as well, it turns out the ratio was the golden ratio. And it's very handy, and it's used in nature. It's used for many things that look beautiful. It's even used for portraits sometimes if you really know what you're doing. And it's overall a really cool constant in mathematics. Now, using our definition of how we found the golden ratio, we said this was the solution to x squared minus x minus 1 equals 0. So if we rearrange the terms, that means x squared is equal to x plus 1. So if we think about what that means for a second, that means something 1.618 ... squared is equal to 1.618 ... plus 1. So that's a really cool property of this number too. 1.618 ... squared is equal to 2.618 ... So we just added 1 there. Really handy. And the golden ratio is honestly seen everywhere. It's even seen in the Fibonacci sequence and there's many claims for the golden ratio as well, and it's all found all throughout nature and known as like the beautiful constant. So yeah, if you have any questions, let me know. In summary, the solution for today is 1 plus the square root of 5 over 2, aka the golden ratio. Let me know if you guys want to see a specific video. Leave it in the comments below. Leave any questions. Overall, thank you guys. See ya.